Ha. So your question says that, Sn, right, plus 2H plus, okay, gives rise to Sn2 plus H2. We'll take some time explaining this problem. Sn plus 2H plus is equal to Sn2 plus H2, right? So if the solution, the concentration, now they are telling that let's forget about something else. So let's find the oxidation and the reduction part separately. It's a standard reaction. Even the hydrogen is itself being given, so it's a standard reference reduction potential of Sn which has been given. When had it occurred in standard states, what would have been the EMF of the cell? So that would have been Sn2 plus 2 electron, okay, giving rise to Sn. It's a straightway reduction reaction. That means it's a cathode reaction. It's a cathode reaction. Otherwise, student will think that, okay, Sn is being oxidized to Sn2 plus, so Sn undergoes oxidation. That will be pretty wrong. The answer is exactly opposite. We will explain why. Sn is not being oxidized in this reaction. This is the standard state of reaction. It's not happening. This is not happening because of two things. The Sn concentration is 10 to the power minus 2 molar we say actually concentration. So, and pH is 5. I don't know whether this reaction will occur or not. Why not? We'll explain. So this is the thing. So for this, it's minus 0.136 volts, right? Minus 0.136 volts. And for hydrogen, we know it's a 0. So this is a reduction reaction. This is only the oxidation reaction under normal circumstances. Or have I done a mistake again? Oh, I'm sorry. I've done a mistake again. Sn is leaving oxygen, right? So this is an oxidation reaction. So oxidation reaction and anode. Sand. I'm sorry. Please make the corrections. So Sn is leaving electron to be and getting oxidized. That what happens, in a standard state. That happens in a standard state. Normally it should happen. But whether it happens or it doesn't happen depends on the concentration of Sn and hydrogen. That's why your non-standard state comes into play, where we say that E is also dependent of ln. In this case, for this case, if I need to write the E, because E is the important thing that will determine whether this reaction will take place or not. So E equal to E0 minus RT by NF ln, that will be, your product is Sn2 plus multiplied by pH2 Sn concentration and multiplied by H plus square. This is very important. This is how you write your first equation. So if everything had occurred in their standard state, so this part would have been 0. So ultimately E equal to E0, and you had this reaction. You're not having this reaction because of two things. Because of this. This reaction will happen only if E is greater than 0. So also remember, this is also a checkpoint. A reaction in electrochemical scale, if E is greater than 0, this will move in this direction. That is, this reaction will take place. Right? If E is greater than 0. Why? For this, if I need to write E0 for this particular reaction, what would have been the E0? If I need to write the E0 form, anyway I have to write the E0. So I will explain how the E0 will be written. Anyway. So what are the unknowns here? You need to find the EMF of the cell. The EMF of cell greater than 0. Yes, this oxidation, this reduction will take place. Sorry, this oxidation will take place. I'm making this mistake again and again. This oxidation will take place. Yes, E is greater than 0. Yes, this oxidation reaction takes place. E equal to 0. This is equilibrium. No oxidation, no reduction. E is less than 0. The reverse reaction is true. Sn2 plus is being reduced, and hydrogen is actually oxidized. The reverse reaction is true. So whether this reaction is true depends on the total EMF of the cell. This E greater than 0, yes, my reaction is okay. So the first step in solving this problem is finding the E0. What is the E0? Let's go back to again to the basic. E0 is nothing but E right minus E left, or E cathode minus E anode. Everything in terms of reduction potential. So E0 is given for cathodic reaction. For this reaction to take place, Sn minus 2 electron to Sn2 plus. The value is given, I guess. What is the value? Minus 0.136. Okay. So for this half cell, again you need to determine which is right, which is left. So this is, again, very careful, left. This is an anodic reaction, so it occurs at the left, right? So whatever value has been given, minus 0.136. This is the left, E left, half cell. What is the right hand side? That is the hydrogen, or I just write hydrogen is taking up those 2 electrons, 2H plus, to produce H2. This is cathode. What is the EMF? 0. This is the reference, right? For hydrogen we know E0 is 0. This is the reference based on which everything is measured. So right hand side, this is 0 and this value. If we plug this 2 in, what will we get? We'll get the E0 of the cell. We'll get the E0 of the cell. What will be the E0 of the cell? That is 0 minus 0.136. Okay, so 0.136 volts is the E0 of the cell, which has not been given directly. That is the thing. People will blindly put this 136 into E0 value, but that is not the thing. This is how it 0.136, how it becomes 0.136 from minus 0.136. If you don't understand, you will simply put this equation. You remember I've talked about this equation. E equal to E0 minus RT by NF ln Sn2 plus concentration multiplied by EH2 by Sn concentration multiplied by H plus square. So people who don't understand this concept, this particular concept, will simply take this minus 0.136 value, plug it here, and they will get an absolutely wrong answer, absolutely wrong results. Okay? So that will be a wrong result. Please remember this. If you don't understand this, you will get a wrong result. So for here, look at here. I know this part, E0 I know. Now I need to calculate Sn2 plus, this whole thing. How do we calculate that? It's been given, everything has been given. We're calculating the E of the cell. That's it. So if I substitute that, I have done that hard work. You just do it for yourself. So it will be something 0.136 minus RT by NF. If you just substitute all those, 8.314 multiplied by, what is the temperature? I guess it's the 25 degrees centigrade, right? Room temperature, 298 K. Yes, 298 divided by how many electrons? It's being given also. There is a Simply there are 2 electrons. There Sn plus 2. So 2 electrons. N is 2. Simply no. Sn goes to Sn2 plus. So it leaves 2 electrons, or you can just add here 2 electrons. Anyway. So 2 electrons, 2 multiplied by Faraday's constant 96500. See, I need to take care of the hydrogen concentration. So it's better that I write ln in terms of logarithm. So if I just do that, so just write it. Ln x base E is equal to 2.302 log x base 10. I hope you remember logarithm. I haven't forgot everything. I was just joking. Okay, so I'll just put that. I'll just take it outside into 2.30. How much I have taken the value? It's 2.302. Okay, pH2 is 1. It's given 1. Sn is 1. Nothing has been mentioned. So what I'm left up with in the bracket, I will have logarithm of Sn2 plus, right, minus twice this 2 comes here, logarithm of H plus, right, square was there. This is what we left up with. If you just solve this, entire thing. I'll just recalculate once more. 0.314 multiplied by 298 divided by 2 into 96,500. It's 0.0128 multiplied by 2.302. It comes to be 0.02955. So it's almost right here, 0.136 minus 0.02955, 0.02955. Let's take some. Okay, the rest of the part is very easy. Sn2 plus concentration is given 10 to the power minus 2, I guess. Molal, yes. So 10 to the power minus 2, it's a log base 10, so minus 2 comes out. Now minus logarithm of H plus ion is your pH, right? Minus logarithm of H plus ion is your pH. So that value is set to be 5, I guess. So if I take this minus, so it becomes 5 into 2. You understand? Minus logarithm of H plus, we put pH, which is set to 5 here, given. So I put it here, 2 log 5 into 2. So if I do the calculation again, so it becomes 0.136. I just write it top. You don't understand otherwise. So it becomes my final result because 0.136 minus this part will become 8 multiplied by this. How much it becomes? Just calculate for yourself. 0.136 minus 0.02955 multiplied by 8, right? The result becomes minus 0.1004 volts E. So E is my minus point, it's very important, 1004 minus 0.1 volts, or we can say. So E is less than 0. Negative. E less than 0 means my reaction, this Sn2 or whatever, what was there? Again, I'm confusing. Sn plus 2 electron to Sn2 plus. That's what I am confusing sometimes. Sn minus 2 electron. This reaction, this way the reaction has been formed, right? Sn2 plus. Or the total reaction Sn plus, let's try the 2H plus gives rise to H2, won't take place. This reaction won't take place. This won't take place. Why? Because my reduction potential is less than 0. So the opposite direction, in the opposite, the reverse reaction will be true. That means now Sn2 plus, Sn plus 2H plus, this reaction is true. SN2 plus H2. So SN, this one is being reduced, hydrogen being oxidized. I'm sorry, what I'm talking about. So hydrogen is oxidized, SN is reduced, right? The directionality has changed. This is what it means. So now look at the options which you have been given. SN undergoes oxidation. SN is not undergoing oxidation. Okay, so A is not true. Hydrogen plus undergoes reduction. Hydrogen is not undergoes reduction. Actually, is being reduced. H2 is actually undergoing oxidation. So H plus is not being reduced because H plus is not converting to H2, right? Please understand this. So what is the third direction? SN2 plus undergoes reduction. No, SN2 plus doesn't go under. SN2 plus undergoes reduction. So your option C is the correct answer here. SN2 plus undergoes reaction. No reaction, not true. If my E have been 0, the D would have been true. No direct reaction. Because E is less than 0, the reverse is true. SN is undergoing reduction. Okay? I guess you have understood a lot from this reaction. Fine.